Have you ever looked at a chemical equation and felt like you were staring at an impossible puzzle? You need to satisfy the law of conservation of mass, but getting those coefficients right can feel like pure guesswork. Well, today we're not just guessing, we're mastering the process. I'm going to show you 3 powerful methods to balance any equation, from the simple to the complex. First, we'll dive into the classic tried and true method of inspection, perfect for quick, simple reactions. Level up with the algebraic method, which turns chemistry into a solvable math problem, giving you an answer you can always trust. And finally, for those massive head-scratching equations, I'll show you a game-changing hack, how you can use your graphing calculator and matrices to find the solution almost instantly. This is the pro-level technique you won't find in every textbook. So grab your periodic table, a notebook, and your calculator, and by the end of this video, you'll be able to balance any equation thrown your way. So let's get started. To satisfy the law of conservation of matter, matter can neither be created nor destroyed in a chemical reaction. So I need the same number of calciums on both sides of this reaction. Same thing with potassiums, chlorine, and so on and so forth. So what I would suggest doing is to start with something that appears once on either side. Okay, so I would choose either calcium, potassium, phosphorus, any of those. They appear once on either side. If I have 1 calcium on the left, 3 calciums on the right, I could go with putting a 3 here. So I have 3 calciums versus 3 calciums. Potassiums, I have 2 potassiums on the left side. I have 3 potassiums on the left. I need 3 on the right. So if I put a 3 there, my calciums seem to be balanced, and my potassiums. Let's look at my chlorides. I have 2 times 3 is 6 chlorides, but here I have 3. So I know that I need a 6 here, okay? So that affects my potassium. So I'm going to have to put a 2 here in front of potassiums so that potassiums will balance. So now I have 3 calciums, 3 calciums, 6 chlorides, 6 chlorides, 6 potassiums, 6 potassiums, 2 phosphates, and 2 phosphates. We were able to balance this one quite easily using the inspection method. I would start with sodium here. Well, it appears once on each side, and I always wait and do my H's and O's last because I have H's in 2 places. Let's start with sodium. I have 1 sodium, 1 sodium. They're balanced. My hydrogens, I have 2 hydrogens on this side and 3 on the other. So I have an even-odd problem. No matter what I multiply this by, I always get an even number. If I add an even plus an odd, I always get odd. But if I add 2 evens together, I always get an even number. So I need to make my hydrogens even. So I'm going to multiply this by 2. That gives me 2 sodiums. Go back and fix that. So that's 2 sodiums, my oxygens. I have 2 oxygens on the right side. So I need to fix it on this side. Let's put a 2 here. All right, so I have 2 sodiums, 4 H's, 2 plus 2 is 4 H's, 2 O's, 2 O's. So this one is now balanced. Okay, so here I have C's, H's, and O's. I have 2 C's here. I have 1 C here, so let's put a 2 in front. I have 6 H's. Here's 2. 2 times 3 is 6. That will give me 6 hydrogens. So my carbons and hydrogens are now balanced. Okay, let's look at my oxygens. I have 2 on the left side. On the right side, I have 2 times 2 is 4 plus 3 is 7. I have 7 halves here. Well, I can't have halves. So let's multiply everything by 2. So multiply this by 2. This by 2 gives me 7. Okay, so now I have 4 carbons, 12 hydrogens, 14 oxygens, 2 times 4 is 8 plus 6 is 14 oxygens. So with simple equations, it's much faster to do them by inspection than any other method. Okay, let's try algebraically. What I would do first is I will give each chemical formula a variable. So I'm going to let this be variable A, B, C, and D. All right, I'm going to list my elements. I have carbon, hydrogen, and oxygen. I want to write an algebraic equation for each one of these chemical formulas. So the C6H14, I have 6 carbons in A. I have 0 carbons in B. We'll treat the yield sign like an equal sign. I have 1 carbon in C. I have no carbons in D. For hydrogens, I have 14 hydrogens in A plus 0 in B. I have 0 hydrogens in C, but I have 2 hydrogens in D. All right, for oxygen, I have no oxygen in A. I have 2 in B. I have 2 oxygens in C plus 1 in D. Okay, so A equals, B equals, C, and D equals. I'm going to let a variable equal some value. I want the smallest variable. I'm going to let it equal 1. It takes 6 A's to equal 1 C, so A must be much smaller than C. It takes 14 A's to equal 2 D, so I know A is very small compared to D. So I'm going to let A equal 1. So I'm going to put it there. And so in this equation, I'm going to have 6 times A, which is 1, equals C. So C equals 6. In this equation, I have 14 A's equals 2 times D. So D then must equal 14 halves, or 7. In this last equation here, I have 2 B's equals 2 times C plus D. That gives me 19. So B equals 19 halves. Well, I can't have halves there, so let's multiply everything by 2. So there's a 2. This becomes 19. This becomes 12. This becomes 14. So my balanced equation will be, I have 2 here, 19 here, 12, and 14. Always check to make sure it's balanced. So 2 times 6 is 12 carbons. I have 12 carbons. I have 2 times 14, 28 on both sides. And for my oxygens, I have 2 times 12 is 24, plus 14, which is 38. 19 times 2 is also 38. So this is correct. Okay, let's try a larger problem. Again, as before, I'm going to say this is A, B, C, D, E, and F. I'll list my elements: calcium, phosphorus, oxygen, and silicon. So let's write an algebraic equation for these. So I have 3 calciums in A, so that's 3A. I have none in B, none in C. I have 1 in D. For phosphorus, I have 2 in A, 9 in B, 9 in C. I have 4 in F. For oxygens, I have 8 in A. I have 2 in B. I have 3 in D. I have 1 in E. Silicon, I have 1 in B and 1 in D. Carbon, I have 1 in C. And I have 1 in E. Okay, let's decide which variable is the smallest. Okay, F looks much smaller. So I'm going to let F equal 1. So if F equals 1, then this equation, 2A equals 4. So A would have to equal 2. All right, so 3 times 2 equals D. So D must equal 6. If D is 6, then B is 6. Let's take this long equation here. So it'll be 8 times 2 plus 2 times 6 equals 3 times 6 plus E. So this is 16 plus 12 equals 18 plus E. So E will have to equal 10. If E equals 10, then C equals 10. So let's check this. So let's go ahead and substitute in. So I have 2 here. I have 6 here. 10, 6, 10, and 1. So 2 times 3 is, I have 6 calciums. I have 2 phosphorus. Times 2 is 4. I have 4 phosphorus. Oxygens, 2 times 4 is 8. 2 times 8 is 16. I have 12 here. So that's 28. 3 times 6 is 18 plus 10. So that balances. 6 silicons, 10 carbons, and 10 carbons. So everything is balanced. Okay, so we're going to label A, B, C, and D. F, E, S, and O. So for iron, I can say that I have 1 in A equals 2 in C. Sulfur, I have 2 in A equals 1 in D. For oxygen, I have 2 in B equals 3 in C plus 2 in D. Okay, so which one is the smallest? It looks like C is smaller than A, and A is smaller than D. I'm going to let C equal 1. So A equals 2 times 1, so A equals 2. 2 times 2 equals D, so D equals 4. 2B equals 3 C's plus 2 D's. So 2 and 4 is 8. So 2b equals 11. So b equals 11 halves. So let's multiply everything by 2. Gives me a 4, 11, 2, and 8. Let's check it and see. 4, 11, 2, and 8. I have 4 irons. 2 times 2 is 4 irons. I have 2 sulfurs times 4 is 8. I have 8 sulfurs. 22 oxygens. 2 times 3 is 6. Plus 16. Hey, that balances. Okay, so let's go ahead and label my variables A, B, C, D, and E. I have copper, hydrogen, nitrogen, and oxygen. Okay, so I have 1 copper in A. I have 1 in C. Hydrogens, I have 1 in B. That equals 2 in E. For nitrogen, I have 1 in B. I have 2 in C plus 1 in D. Oxygens, I have 3 in B equals 6 in C plus 2 in D plus 1 in E. Okay, I'm going to let A equal 1. So A is 1, C is 1. Okay, let's take this equation. I know that B is equal to 2E up here. So I'm going to plug that in here. Okay, so that means that 2E is equal to 2C plus D. I know that C equals 1. So 2E equals 2 plus D. So D is equal to 2E minus 2. All right, let's take the next equation. I know that B is equal to 2E, so it's going to be 3 times 2E equals 6 times 1 plus 2D. That's going to be 2 times 2E minus 2 plus E. This is 6E equals 6 plus 4E minus 4 plus E. This will give me, this gives me E. It's equal to 6 minus 4. So E is equal to 2. I know that B is equal to 2E. So B is equal to 2 times 2, which is 4. I know that D is equal to 2E minus 2. So this is 2 times 2 minus 2. So D is equal to 2 also. So I have 1, 4, 1, 2, and 2. So I have 1 copper, 1 copper. I have 4 hydrogens, 4 hydrogens. 4 nitrogens. I have 2 plus 2 is 4 nitrogens. 4 oxygens. 3 times 4 is 12. So I have 6 plus 4, which is 10, plus 2 is 12. So that balances. All right, let me show you how to do it with a calculator. Again, I want to go ahead and label A, B, C, D, and E. All right, I want to isolate the last variable. Okay, so what I'm going to do is I'm going to move my yield sign over here. Okay. So this is going to be minus, and this is going to be minus. I want this isolated. So I took both of those over to this side. Okay, so I have coppers, hydrogen, nitrogen, and oxygen. I want to do almost the same thing I did earlier, but I'm going to set it up into matrices instead, where this is variable A, variable B, variable C, and variable D. Have 1 copper in A, have 0 coppers in B, have -1 coppers in C, have 0 in D. I have a separate matrix over here, E, and I have no coppers in E. So I'm going to call this matrix A. I'm going to call this one matrix C. For hydrogen, I have none in A, I have 1 in B, 0 in C, 0 in D, I have 2 in E. For nitrogens, I have 0 in A, 1 in B, -2 in C, I have -1 in D, 0 in E. Oxygens, I have 0 in A, I have 3 in B, I have -6, -2, and 1. All right, so all we have to do now is plug this into our calculator, and let me show you the math we have to do. I'm going to say that matrix B contains the variables A, B, C, and D. I'm going to say then that matrix A times matrix B is equal to matrix C times E. I want to solve for matrix B here. Matrix B is equal to the reciprocal of matrix A times matrix C times E. And I know that E is going to equal to the determinant of matrix A. So let's pull up our graphing calculator, and I'll show you how to key this into the calculator. With my calculator here, I want to go to second and find the matrix, which is the reciprocal key. I want to edit matrix A. I have 5 variables. So I need to reduce that by 1. So that's 4. I want a matrix which is 4 by 4. It has to be the same number, not necessarily even, but they have to be the same. Okay, so my values was 1, 0, -1, 0, 0, 1, 0, and 0, 0, 1, -2, -1, 0, 3, -6, -2. All right, I have populated matrix A. I'm going to go second, quit. Then I want to populate matrix C. So I go second, matrix, cursor over to edit, and down to C, and press enter. This will be a 4 by 1. Now our values were 0, 2, 0, and 1. Second, quit. Now we're ready to do the math. Okay, so we said that the last variable, e, is equal to the determinant of a. So I'll go to second, matrix, cursor to math, and there's the determinant. So the determinant of matrix A, second, matrix A. So I know that the value e is -2. Okay, so now I'm going to do the other math. So I'm going to go second, matrix A, reciprocal, times matrix C, times the last variable, which is the determinant of a, which is -2. All right, so those are all my values. So a is -1, b is -4, c is -1, d is -2, and e is -2. So our values were -1, -4, -1, -2, and -2. So if I multiply by -1, I would get 1, 4, 1, 2, and 2. So let's plug it in. So I have 1, 4, 1, 2, and 2. So back into the original equation, then I would have 1 copper, 4 hydrogens, 4 nitrogens, 2 plus 2 is 4. Oxygens, everything's the same. I generally wait and do the calculator. If it takes me more than a couple minutes to do the algebra, it's faster once you get the hang of it. One thing that's very important is that this has to be the same number of rows and same number of columns. All right, this next one's quite long. So we'll be A, B, C, D, E, and F. That's 1, 2, 3, 4, 5, 6 variables. So I need a 5 by 5 and a 5 by 1. All right, so I have sodium, iodine, oxygen, hydrogen, and sulfur. 1, 2, 3, 4, 5. Okay, that works out great. So this is going to be A, B, C, D, and E. All this is matrix A. And all this will be F. This will be matrix C. For sodiums, I have 1 in A, 1 in B. Remember now, we're going to take all of this. Just remember, we're going to bring it over there and change the sign. Okay? So I have -1 in C, -2 sodiums in D, have no sodiums in E or in F. For iodine, I have 1 in A, have 0 in B, 0 in C, 0 D, 0 E. I have 2 in F. Oxygens, I have 3 in A, 3 in B. I have -4 in C, -4 in D, -1 in E, 0 in F. Hydrogens, I have 0 in A, I have 1 in B, -1 in C, I have 0 in D, minus 2 in E, and 0 in F. Sulfurs, I have 0 in A, 1 in B, minus 1 in C, minus 1 in D, 0 in E, and 0 in F. All right, so F is going to equal the determinant of matrix A. To solve for the variables A through E, I'm going to say the reciprocal of A times matrix C times the determinant of A. And that will give you my answer. Let's go to my calculator and plug it in. Here we go. I'm going to enter my A first, so second matrix, edit A, and this is going to be a 5 by 5. So I'm going to go across, so it's 1, 1, minus 1, minus 2, 0, 1, 0, 0, 0, and 0. Third row is 3, 3, negative 4, negative 4, and negative 1, 0, 1, negative 1, 0, negative 2, and last row is 0, 1, negative 1, negative 1, and 0. Hit second and quit. All right, second matrix, let's go down to C. So I'm going to edit C. It's going to be a 5 by 1. And those values are 0, 2, 0, 0, and 0. Second quit. Okay, so let's find my F. So F is equal to the determinant of matrix A. So I'm going to go second matrix, go to math, choose determinant, second matrix, choose A. So determinant of A. So I know that my last variable, F, is a 2. Okay. So let's solve for the A, B, C, D, and E. Second matrix, A reciprocal times matrix C times the determinant of A, which we calculated was a 2. So A is 4, B is 10, C is 6, D is 4, and I have a 2 for E. Hey, all those are divisible by 2, so we'll fix that in just a moment. So that was 4, 10, 6, 4, 2, and 2. So let's divide this by 2. So that means that this is a 2, a 5, 3, 2, 1, 1. So it's 2, 5, 3, 2, 1, and 1. All right, so I have 2 sodiums and 5 sodium, that's 7. 3 plus 4 is 7. For iodines, I have 2 iodines, 2 iodines. For oxygens, I have 2 times 3 is 6. I have 3 times 5 is 15, so that's 21. So 3 times 4 is 12, plus 8, plus 1. I think that's the same, isn't it? 6, yes, 21. All right, so it looks like everything is balanced. Okay, this next one is really tricky. I chose this on purpose, and I'll show you why in just a moment. So again, A, B, C, D, and E. Okay, now remember, we're going to take these over to the other side. So they're going to be negative. Okay, so I have carbon, hydrogen, chlorine, sodium, and lead. Okay. So I have A, B, C, and D. All right. Here's the problem. I have 4 variables, but I have 5 elements. So we're going to have to strike one of these out. But let's just go ahead and fill it all in, and then maybe later on we'll decide which one we'll strike out. Because it has to be the same number of rows and the same number of columns. All right, so for carbon, I have 2 in A. I have 0. 2 times 4 would be a negative 8. 0. And 0. For hydrogens, I have 5. 0. Negative 20. 0. And 0. For Cls, I have 1, 0, 0, negative 1, 0. For sodiums, I have 0, 1, 0, negative 1, and 0. For leads, I have 0, 1, negative 1, 0, and 1. I'm going to have to strike one of these out. So I'm going to just pick one and see if it works. So I'm going to strike this row out all the way across. So now it gives me a 4x4 and a 4x1. So let's go to the calculator now and see how this works. All right, so let's enter matrix. I'm going to go to edit A. It's going to be a 4x4. So be a 2, a 0, negative 8, 0. I'm skipping the hydrogen row. Be 1, 0, 0, negative 1, 0, 1, 0, negative 1. Last row is 0, 1, negative 1, and 0. Then second, quit. Let's populate the matrix C. So I'm going to go to matrix, edit, cursor down to C. It's going to be a 4x1. It's going to be 0, skipping hydrogen row, 0, 0, and 1. All right, let's quit. I know that the variable E is going to be equal to the determinant of A. Second matrix, math, go to determinant. Second matrix, choose A, and press enter. I know that E is going to be negative 6. So let's solve for A through D now. So it'll be second matrix, A, reciprocal, times second matrix, cursor down to C, times negative 6. So A is negative 8, B is negative 8, C is negative 2, D is negative 8. So this is negative 8, negative 8, negative 2, negative 8, negative 6. So I can divide all this by negative 2. That gives me a 4, 4, 1, 4, 3. So 4 here, here, 1, 4, and 3. So 8 carbons, 2 and 4 is 8 carbons, 20 hydrogens, 20 hydrogens, 4 Cls, 4 Cls, 4 NAs, 4 NAs, 4 PVs. I have 1 plus 3 is 4 PVs. So it's balanced. And there you have it. 3 ways to conquer any chemical equation, whether you prefer the quick intuition of inspection to the guaranteed solution of algebra, or the speed of the matrix method. On your calculator, you have the tools to ensure every reaction you write respects the law of conservation of mass. If this video helped you, please hit the like button and subscribe for more chemistry videos. Your support helps me to make more videos just like this one. Thanks for watching, and I'll see you in the next session.